Welcome back to tutorial 2 and the mesh current method. In this video, we will be calculating the current I0 flowing through the 1 ohm resistor using mesh current method. So in our previous video, we learned that in using the mesh current method, you have to know the number of meshes in the circuit. And in this circuit, we have 3 meshes. You can consider the top here as one mesh, so mesh 1, mesh 2, mesh 3. So we are going to assign different current to the meshes. Alright. So let's say this is our first mesh. So we are assigning a current. I'm using the clockwise direction. So let's assign a current in this mesh. And the current is moving in the clockwise direction. I1. There's another current moving in what? This mesh. Let's call that current I2. There is another current moving in this mesh. Let's call that current what? I3. So after assigning the current, what we do is we write Kirchhoff's voltage law for each of the mesh. We take one mesh, we write the KVL equation, we move to the next one. So let's start with the mesh 1. We have KVL for mesh 1. So in this mesh, how many elements are we going to consider? We have 4 in this mesh. 2 is in the 2 ohms here is between what? Mesh 1 and mesh 2. There is 1 ohm here between mesh 1 and what? Mesh 3, and there is 8 volts here. The 8 volts is part of mesh 1 and also part of what? Mesh 3. So let's see how we can get our KVL equation here. So we can start from any of the elements. Let's start from this one. Alright, so we are going to sum the voltages in that mesh and equate it to 0. But as I said, if the current I1 is flowing through this one, there will be a voltage here. What will be the polarity? The current is moving from the bottom, so your plus, it's hitting here first, your plus will be here, your minus will be here. This current I1 is also moving in the 2 in this direction, plus, minus. The current through 1 using the I1 is what? Plus, minus. This is a voltage source, its polarity is given. So let's sum the voltages in that loop starting from here. So the voltage here will be minus what? 4I1. So I have minus 4 times the current I1. We have 2 ohms, but the 2 ohms is between mesh 1 and mesh 2. So current in the 2 ohms is what? I1 minus I2, because it is between these 2 meshes. So we have minus 2 times the current I1 minus what? I2. Then we move on to this 1 ohm. This 1 ohm is also between mesh 1 and what? Mesh 3. So if we count minus 1, the current is I1 minus what? I3. Then we move on. Is there any other elements? We have a voltage source. And in that voltage source, we are moving clockwise. So enter positive and leave the negative. So that's a drop. So minus 8. And that is giving us what? 0. KVL. The algebraic sum of voltages is equal to 0. So let's simplify this and see. We have minus 4I1 minus 2I1 plus 2I2 minus I1 plus I3 minus 8 is equal to 0. Let's group our variables. We have I1, 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 which gives us minus 7 I1 plus 2I2 plus I3 is giving us what? 8. So we can call this our first equation. That's the KVL in mesh 1. So we move on to KVL in mesh 2. So KVL in mesh 2. Right, let's move to mesh 2. And in mesh 2, how many elements are we going to consider? How many elements are in that mesh? We have 10, we have this voltage, and we have 2. They are all in this mesh. So we have to involve all the 3. Don't leave one out. You can start from any of them. Let's say we are starting from 10. The current flowing through the 10 is what? I2. In what direction? In this direction. So if you enter the 10 here, you have plus, minus. The current through the 2. Where is it starting from? It is moving in this direction. So it will enter the 2 here, then leave here. So we have our plus, minus. You can see this plus minus is different from this plus minus. This plus minus was given to this resistor based on what? I1, when we're in I1, in mesh 1. But now we are in mesh 2, so the current flowing through the 2 is what? I2, which is plus minus. But don't forget the 2 is still between this and that. So if we are in mesh 2, the current through the 2 will be I2 minus I1. Alright, good. So let's start from 10. If you are starting from 10, we will leave the negative. So we have minus 10 times what? The current, I2. Then we come here, we will enter negative and leave positive in this direction. Negative and leave the positive. So positive what? The voltage, 6. Then we come to the 2. We will enter positive and leave negative. So it's a negative voltage. Negative 2 times, what's the current there? I2 minus I1. I2 minus what? I1. Giving us what? 0. That's the KVL in mesh 2. So let's simplify this. I have minus 10 I2 plus 6 minus 2 I2 plus 2 I1, giving us what? 0. So after grouping, we have 2 I1 minus 12 I2 is giving us what? Minus 6, equation 2. So equation 2 is what? 2I1 minus 12 I2 equals minus negative 6. We are left with the final mesh, which is mesh 3. So let's write KVL in mesh 3. So KVL in mesh 3. Good. So what's happening in this mesh? In this mesh we have what elements? 6 volts, 5, 8, and 1. Okay, we can start from any of them. Let's say we are starting from what? The 6 volts. So from the 6 volts, we are moving in this direction clockwise. We will enter positive and leave the negative. So where we are leaving is negative. So negative what? 6. Then we come here. This is plus minus. So that one we will leave what? The negative. So negative, the voltage there, which is 5 times the current, I3, because I3 is flowing through this. We will come to what? The voltage source here. We are moving in this direction. So we will enter negative, leave the positive. So positive what? 8. Then we come to what? The final element, which is 1. But the polarity on this one will be what? Plus minus, based on what? I3. And the current through 1 is I3 minus I1. Okay, so that one will be minus the resistor times the current, I3 minus I1, giving us what? 0. The algebraic sum of voltages in a loop is equal to 0. So let's simplify. We have minus 6, 5I3 plus 8 minus I3 plus I1 is equal to what? 0. So from here we have I1 is here. We have minus 6 I3, I1 minus 6 I3 is equal to minus 2 as what? Our third equation. Our third KVL equation. So now we have how many equations? We have 3 equations and the variables are what? 3. So we can solve these 3 equations simultaneously and get our I1, I2, and I3. So solving this simultaneously, we are going to get, let me use the calculator to point, minus 7, 2, 1, 8. I have 2 minus 12, 0 there. I3 here is what? 0. So we move on to what? Minus 6. And I'll come in, I1 is 1. The I2 coefficient here is what? 0. 0 minus 6 minus 2. So after solving, you get your I1 to be equal to minus 40 on 39 amperes. You get your I2 to be 77 on 234 amperes. Then you get your I3 to be 19 on 117 amperes. So these are your mesh currents. But the question is asking us to find what? Current I naught, which is the current flowing through the 1 ohm resistor. But in the question, the direction of that current was said to move up. Okay, we know current I naught is flowing through 1, and the current through 1 is the difference between what these two. But the I naught is moving up, which means between these two currents, the one moving up that is in the same direction as the I naught should be considered positive. So between these two, I3 is the one moving in the same direction as the I naught. So the current through the one is going to be I3 minus I1. So our I naught is I3 minus what? I1, which is 19 on 117 minus I1, which is minus 40 over 39. And that one is giving us, so we have 19 on 117 minus 40 on 39, which gives us 1.188 amperes as what? Our I naught. So the current flowing through 1 ohm resistor is equal to 1.188 amperes. So that's the end of this tutorial video. Thank you very much.